In this section of the general compliance training, we'll go over the stormwater retention volume, or SWRv, and how to calculate it. As mentioned in the previous video on the stormwater management requirements, the SWRv is the regulated stormwater volume. So this is the volume that must be retained on a site. So let's take a look at example here. This example number 1, which is an existing school that is going to be renovated. So the renovation is planned for the entire interior of the building. Let's say that this is a substantial improvement. All right, the substantial improvement meaning that the renovation cost is 50% or greater than the existing assessed value of the building. So we have a substantial improvement, and then we also look at the building area. We want to know, is this going to be a major substantial improvement? Because the building area exceeds 5,000 square feet, then yes, we have a major substantial improvement activity. So we want to calculate the SWRv using the equation that we saw before, which is as follows. The SWRv equals the precipitation depth times this composite of the land use types, the impervious area and the compacted area, multiplied each by their associated factor for the precipitation to runoff ratio. So we can see for this building, we need to know first what type of activity is going on, which we determined is a major substantial improvement, and that tells us what precipitation depth we're going to use for this calculation. And then we need to know what is the impervious area and what is the compacted cover area. So in this case, we have no compacted cover because the building area is the only part of the site that's being renovated. So all of our area is impervious area, so 37,250 square feet of impervious area. And the precipitation depth, because it's a major substantial improvement project, is going to be 0.8 inches. So plugging in those numbers, we get a SWRv of 2,359 cubic feet, or 17,646 gallons. Looking at another example here that's a bit more complicated, we have an existing building here outlined in red that's going to be renovated. And then there's also a parking lot and grass area next to it that's going to be developed into a new building. And then to meet the stormwater regulations, they're going to install a bioretention here to the left of the renovated building. So overall, the total area is 23,220 square feet. And the renovated new building and bioretention areas are shown there as well. So we need to see what the SWRv is for this site. And it's going to be a function of the activities that are going on the site and the land covers. So here's our equation for the SWRv. And first we want to know what precipitation depth are we going to use in this equation. So let's look at our activities on the site. We can see that there's a bioretention area and a new building construction. Both of these areas are going to constitute land disturbance. And we can see that the combined footprint there of the 15,200 square feet of new building area and the 3,795 square feet of proposed bioretention area exceed the 5,000 square feet threshold to constitute a major land disturbance. So the precipitation depth for those areas is going to be 1.2 inches, whereas we have this existing building that's going to be renovated at the major substantial improvement precipitation depth of 0.8. So you can see here we have used the major substantial improvement 0.8 inch precipitation depth, applying that to the 4,225 square feet of the renovated building. And then the major land disturbing area precipitation depth of 1.2 inches applied to the combined footprint of the new building construction and the bioretention that is proposed. And we get a SWRv from that of 2,072 cubic feet, or 15,499 gallons. Now you may wonder why the bioretention area was entered in as if it were impervious area. And the reasoning behind that is that the SWRv is a calculation of the runoff that's generated from a site that must be retained. So if you think of a BMP or bioretention area, the rainfall that lands on that area is all going to translate into runoff to that BMP since it's landing directly on it. So for that reason, we treat it as if it were impervious area in the calculation and apply the 0.95 modifier to it.